Okay, so it turns out that there is multiple ways of sharing electrons, just as there's multiple ways of sharing items in real life. And if you've ever had siblings or if you have more than one child, you may know that there are definitely multiple ways of sharing. And so one way of sharing is for it to be this ideal state of being, right, where everybody kind of gets equal amount of time with whatever you're working with, and it's just super fair, straight down the middle, right? And that kind of sharing is called a nonpolar covalent bond. And that is when atoms enter into this agreement, they're going to share their electrons, and no one atom kind of pulls the electron closer to their side or keeps the electrons for more time than the other atoms. And so, as you might imagine, similar to real life, this kind of sharing is actually a little bit uncommon. For atoms to enter into this agreement and share perfectly equally is not super common, but it does happen sometimes. And the example here is in a molecule called methane, CH4. And when carbons and hydrogens bond together, they do tend to be nonpolar. And nonpolar covalent bonds, an important part about them is that they actually don't mix well with water. They're what we call hydrophobic. So when you see lots of carbons and hydrogens attached to one another, that is usually an indication of a nonpolar covalent bond and something that would not mix well with water. Okay, so as we were saying, the ideal sharing situation is a little bit rare, both in real life and as we are talking about here with chemistry. And the more common situation when two elements are sharing an electron is that one has kind of a little bit more strength or pull in the situation than another. And you can liken this to the situation that we talked about, like with siblings. There's usually like an older sibling and a younger sibling, and a lot of times they don't share exactly equally, right? So the same thing kind of happens here with elements, and the thing at play here is called electronegativity, which is essentially almost like a gravitational pull of a larger element compared to a smaller element, which effectively kind of means like the disparity between a low atomic number element and a higher atomic number element. It's not perfect, but you can kind of think of that as a general trend. So when two atoms share electrons unequally, we call that a polar covalent bond. It's still covalent because they're sharing. It's just not exactly super equal, so that's what makes it polar covalent. And in the example here we have is water, and what happens here is oxygen is kind of the older sibling. It's like the bigger element, and it has a stronger attraction for the electrons than hydrogen does. So what ends up happening is the electrons spend a little bit more time closer to oxygen and a little bit less time closer to hydrogen. And because of that, we get these slight overall charges between these two elements in this molecule of water. And so it leads to what we call positive and negative poles. And essentially, you can see that from the diagram on the upper right-hand side there, it's got this little like S signal that has a negative sign next to it up by oxygen, and then the same symbol with a little positive sign next to it down by hydrogen. So effectively what happens is when oxygen kind of keeps the electrons closer to its side, then electrons are negative, so that makes oxygen more negative overall. And when hydrogen kind of loses possession of those electrons a little bit more, then it loses those negative electrons and it becomes kind of an overall positive charge. Now, it's not as much of a charge as like when we talked about ionic, where somebody gives up an electron and another one accepts it entirely, because these guys are still sharing, they're just not sharing equally, right? But the fact that a slight negative charge happens to oxygen and a slight positive charge happens to hydrogen is actually what accounts for a lot of the different interesting properties of water that we are going to talk about in this chapter and next chapter.